Hi, my name is Nick Carter, and I'm presenting on Perceptual Filling In from chapters 5 and 6 of Ramachandran's text, Phantoms in the Brain. So what exactly is perceptual filling in? Perceptual filling in is essentially your brain extrapolating information, making inference from information, making assumptions about information that is incomplete in the visual field in order to make it whole and coherent. So most of the time, perceptual filling in, we don't even notice. It's completely outside of our awareness, kind of suggesting that it happens really early on in our visual experience. It happens early on in the brain, so like V1, V2, or V3. And I kind of want to start off by asking the question that Ramachandran asked himself. How sophisticated is the process that the visual system uses to insert information? And to answer this, a lot of researchers have already done a lot of research regarding this and have a wide array of experiments using tricks of the eye. They've asked questions like, what are some of the neural correlates of filling in? What part of the brain is active? They also ask, what are the mechanisms of filling in? Such as, does the brain simply ignore the lack of information, or is it an active process of construction of an image? So a few examples of perceptual filling in. One's called the Troxler effect. Participants look at a single dot, they fixate on it, and then there's a halo around it. And then eventually, after a couple seconds, the halo will kind of evaporate and be filled in by the background, the primary color. This also happens with textures and artificial scotomas. And then the area where I'm going to talk about the most is around the blind spot in all of our eyes. So what are the neural correlates of perceptual filling in? Generally speaking, it's well understood that perceptual filling in happens in early visual and extrastriate regions. So is this an active process that these regions are doing, or is it really a passive process of ignoring and just cutting out information? A lot of research shows that it's an active process. One such line of research shows that, or they used a variation of the waterfall illusion, which is a motion adaptation illusion, and they placed this over the blind spot and then had participants fixate while they did this. And then once the stimuli was removed, they still perceived motion there, even though it was all filled in motion. This indicates that filling in of motion and real motion utilize some of the same mechanisms. And motion requires active processing. It's a moment by moment by moment dealio. And so this kind of elucidates one of the neural correlates. Other experiments have shown that color areas activate. Other research shows that early processing of false contours and such. So what are the mechanisms of filling in, though? Some research has used single cell recordings to look at single neurons that are corresponding from the blind spot to the retinotopic map of V1 and looking at their response to stimuli. Presumably there would be no response in this area, but there are neurons associated with it. So in one test, researchers put progressively larger bars in the person's blind spot in their visual field, and they found that as the bar got longer, there was a stronger response, but it wasn't until the bar crossed the blind spot entirely until this participant perceived it, and there was the maximal response. And this research also showed that the receptive fields of these neurons were relatively large given the rest of the neurons in the V1, which have relatively small receptive fields. So one possible mechanism that has been proposed is through isomorphic theory, and this theory essentially states that there are overlapping receptive fields all the way through our visual field represented on our V1. And